Sketching exponentials using transformations. For the general exponential function, f of x is a to the x minus b plus c. Note here, although we considered y equals a to the kx, which we know is a horizontal dilation, scale factor 1 over k, in the above revision, it is not strictly part of the course. So we can see by looking at this that we have the vertical dilation, the horizontal translation, and the vertical translation. Those things are all a part of this course. So the graph of y equals a to the x has a horizontal asymptote, y equals 0, that's the x-axis. The y-intercept is always at 0, 1, and it always passes through the points negative 1, 1 over a, and 1a. This is actually not that difficult to think about. So y equals a to the x, provided that x is positive, always looks like this. So it asymptotes to the x-axis, which is y equals 0. It always crosses here at 0, 1, because we know that a to the 0, so x is 0, y is 1, a to the 0 is 1. So it will always cross here. It's always going to go through the point 1a, because when x is 1, we just get y equals a. So we'll have the point 1a on here. And when x is negative 1, we have a to the negative 1, which from our index laws we know is 1 over a, which is why it's always going to pass through the point negative 1, 1 over a. Now for a greater than 1, it's increasing, and for a between 0 and 1, it's decreasing. So when I drew this one here, it was for a value of a greater than 1. If a is less than 1, all that happens is the curve comes down the other way, like so. Now, it's easy to see how this works if you just think about something like y is equal to a half to the power x. If you just try a few values of that, it will become apparent. The constant a dilates the graph by a factor of a vertically from the x-axis. If a is negative, we have reflection in the x-axis as well. We're used to that, so we're talking about a scale factor dilation a. The constant b translates the graph horizontally. So right, if b is greater than 0, if you look up here, if b was, say, 3, we'd have x minus 3, which we know moves us 3 units to the right. Or it moves left if b is less than 0. So if we had something like b is negative 2, then this would end up being a to the x plus 2, and we know that would move us 2 units to the left. The constant c translates the graph vertically up or down depending on the value of c. The horizontal asymptote becomes y equals c, because initially it's y equals 0, so when we move up or down, the intercept moves. The y-intercept, which is this point just here, always moves to negative b, a plus c.